And we're now back with Alex. Alex joins us fresh out of the breakout room to tell us about his new venture. These guys came out of stealth back in July, announcing an engagement with Human Longevity Inc. in the USA. So AI deep aging clocks. Alex, please, over to you.
Great pleasure to be back with you again. So by the lanyard, you see that I just changed the company. I have to wear several hats. So I'm the Chief Longevity Officer of a company called Deep Longevity that spun out of InSilico just recently. And the company utilizes deep generative reinforcement learning. So that's kind of AI imagination coupled with AI strategy. So deep generative, meaning that we can make those deep fakes that I've talked about when I was presenting InSilico. And we can make those deep fakes on human data, not only on pictures, but on pretty much every biological data. So I can take a patient subpopulation of, let's say, 1,000 people and extrapolate that patient subpopulation into several million, or sometimes even billions, by just moving age as a dial. We just got a patent on that called age progression regression models and generative biology. And we also combine it with reinforcement learning. So we can now generate the data with a specific objective in mind. And when we work with discrete data types like molecules, so we use this technology as a workhorse for small molecule generation and have multiple proof of concept published that I've talked about in my previous talk. And on Deep Longevity, we use this technology for biological age prediction and monitoring, target discovery, and even trying to work on mental health, depression, motivation, behavioral modification. So it's kind of a new passion, trying to work with really large populational data sets where biological data is connected with behavioral data and identifying common patterns. So disclaimer, Deep Longevity has been acquired by Region Pacific. That's a company in Hong Kong, founded by Jim Mellon, just like Juvenescence. And before that, we raised from really competent investors in longevity. So again, I think that aging is humanity's biggest problem. It's much bigger than any other problem we are facing, more than climate change or inequality, etc. I think that we need to address that problem before anything else in order to prevent economic collapse. And we actually tend to strategically ignore this problem. That's one of the reasons why I'm also looking at the psychology of aging to see how we can change that so people think a little bit more about aging and how to slow it down. So as you know, at this conference, I don't need to talk about this, but I must say that over the past 10 years, there have been many breakthroughs that we, again, tend to ignore when we are in the field because we take them for granted, but really those are major breakthroughs over just one decade. So now we have hallmarks of aging, we have Horvath's methylation aging clocks, we have senolytics, we have clinical trials for NMN, and of course the TAME trial run by the pioneer near Barzilai. What traditional preventive medicine is doing currently is we're not trying to bring the person back to their optimal performance, but rather try to optimize for the optimal performance within a specific age range. And that both the patients and doctors' memories are limited, and their longevity horizons are also quite limited. Again, we tend to strategically deceive ourselves to ignore aging and to operate within the framework that we are going to inevitably age and die. And we just want to be healthy for our own age. So I think that with AI, we can go a little bit further than that and look at this intimate transition between aging associated damage and aging itself and pathology. And with AI, connect those two currently disconnected stakeholder groups, such as wellness and pharmaceutical companies, medical device providers, hospitals, etc., by being able to train on both aging and disease to understand what features are related to diseases and what features are related to aging, and how can we modify those features that change over time in order to slow down the process, or maybe in some cases even reverse it. And what we did in 2015 and then published it in 2016 and patented ubiquitously in multiple data types is the application of deep neural networks to prediction of chronological age in optimal healthy state. We took originally blood tests of many people and used just very simple blood tests to predict age. And age is the most ubiquitous feature that's present in pretty much any data set, so everybody has age. So when you are looking at this diagram, think of regular blood test, albumin, glucose, alkaline phosphatase, etc. So maybe like 50 features going into the input layer of the deep neural network connected so each feature goes into every input neuron, and then you just have one output neuron, age, and you train this deep neural network on millions of samples or hundreds of thousands of samples to predict age in a healthy state as best as possible. And the deep neural network starts learning biology. If you learn on more complex data types like proteomics and transcriptomics, you can actually derive valuable insights like pathways, targets, and even causal graphs, and you can generate synthetic data. So with deep learning, you can do much more than with other traditional machine learning methods. And what we are trying to do now is to go into AI-guided longevity medicine. So we work with clinics like HLI and other advanced clinics that are using those aging clocks to predict patients' biological age, and also use the various AI approaches to look at the list of recommendations that they can perform on a client in order to reverse or slow down the biological aging clock and identify those longevity bottlenecks. So we were trying to go beyond just lifestyle choices and behavioral modifications. We're also looking at alternative drugs and supplements as well. And we're trying to define a new field, longevity medicine. So it's AI-powered preventative medicine, as I define it. We will have a course very soon. It's enabled by cutting-edge research in science, elite personalized medicine, so working with companies like Human Longevity and AI. So to read a little bit more about this, you can look at this paper, so Deep Biomarkers of Aging and Longevity from Research to Applications. We did it with the Scinovation AI Institute together, and trying to currently turn this perspective into practice at Deep Longevity. So at Deep Longevity, we implemented multiple aging clocks. Primarily, I value the transcriptomic proteomic aging clocks, but our workhorse is the hematological aging clocks. So those are very basic blood tests that you would get from your GP that you can upload into the deep neural net and get the predicted biological age. And we have multiple flavors of those clocks. We combine it with data from wearables. We also have a deep methylation clock, behavioral clocks, surveys, microbiomic aging clocks, and even photographic aging clocks. So we don't value each data type more than the other. So we look at this data accumulation as a snowball. So even if you don't have any data to start with, you can start with a survey, a picture, a blood test, and then as the amount of data grows and as the customer gets more interested in their health, they can add additional data types, and they will be combined in a universal manner in a score called age metric. But you would be able to look inside every clock individually. Currently, we implemented 10 clocks in the system, and those are kind of MMA, so mixed martial arts clocks that can handle multiple scenarios. So if you are missing some features, they will still perform maybe with lower quality, but you will still get a number and interpretation. And you can track those clocks over time in the system, add nutritional information, activity information, medical history information, and see how it changes over time. So we work with clinics primarily currently to be able to cater to the doctors and educate the doctors on those aging clocks. So we collect the data for them through mobile apps and web tools. provide recommendations, and then provide the push the doctor's recommendations back to the patients. We have an app. Young AI is already available, so if you want to wait for a couple days, there will be a really cool major update which fixes a lot of bugs because a lot of people started using it. It provides you with longevity insights, sagemetric reports, and it's a well-being companion pocket that collects a lot of data over time, turns it into clocks, and turns it into valuable recommendations. And for a doctor, for a physician, it also provides valuable insights to see, what interventions you're responding to. And we have, again, multiple clocks currently. Currently in the app, we have blood age, photo age, behavior age, anamnesis age, and subjective age. So I think one of the very important clocks that a lot of people ignore is just basically asking the person how old do they feel. And we also, I just submitted a paper for publication on psychological and subjective age clocks trained on millions of people in different countries. The app is also providing you with personalized, easy to do tasks. Currently, they are very simple, like don't drink alcohol, take a survey, don't eat bread, take a selfie, take a behavioral assessment model. And we also provide a competition model where you compare to the others, how you age, and you can compete with your buddy on your lifestyle modifications or supplements, etc. So there are multiple aging clock companies out there. The difference is that we really care about getting this thing into clinical practice. We really care about longevity. I don't value material assets as much. I really think that longevity is the ultimate form of wealth and ultimate good. We currently have the most number of aging clocks that we have patented, published, and validated, and we are validating as we go as well. We don't want to, we prioritize speed over anything else. So I want to, again, get it into clinic as soon as possible. We try to work with clinicians and try to work with some of the best. So Human Longevity and a few others, you will hear about them very soon. So HLI, if you are interested in your health and you're interested in getting as much data about yourself as possible, go to San Diego, or they're now opening regional sites. Get the whole body MRI. You would get a lot of data about yourself, and during the first visit. They're also training an army of longevity physicians right now, and there you would be able to get a very nice collection of aging clocks in the form of a doctor's report with interpretation and with whatever you need to do to correct those aging clocks. And we are, of course, working on multiple research projects there as well. I also think, and just recently I started to realize that there is a very strong mind-body connection. So the age at which you perceive yourself also is very connected to your biological age. And that also connects to the multiple mental disorders like depression, anxiety, stress. And we are now looking at ways to identify the optimal psychological age for you, as we call it, psycho age. We'll look at specifically modifiable features, like, for example, your perception of where you are and how long you're going to live. And we try to identify new ways to stretch your longevity horizons and put you into the younger psychological age as well, and connect it to the biological age. So thank you very much. You can go to deeplongevity.com, look at some of our papers, and we're very collaborative. If you're running a clinic, welcome to partner. We already have several BD people to do that. And if you like to collaborate on a supplement, if you want to do a clinical trial of meta-clinical trial of your supplement, we can do that as well, especially if you have retrospective data. And if you're a pharma company, you can use some of those clocks for clinical trial enrollment. So in some cases, you actually want people to be older than the chronological age. In some cases, you don't want them to be older than the chronological age if you are interested in your experimental group surviving for as long as possible. We basically can provide you with a list of aging clocks for your clinical trial. So thank you very much. And you can email me or add me on WeChat or social networks. Again, we're very collaborative.
Great, Alex. It demonstrates yet again that you're really thinking ahead on a lot of the practical implementations as well, associated with engaging with clinics, data to clinics, and that's really fascinating. And the HLI relationship is great to see as well. Wonderful. Well, I'm sure you're going to get some questions in the breakout room. So thanks again, Alex, for your time today.